Okay, let us start the derivation series. So for the CBSE board derivation number 1, we will do many derivations in this series. So first derivation here for the CBSE board examination 2024. So here the first derivation is derive the expression of electric field at r distance from line charge having uniform lambda. And the meaning of lambda is linear charge density. ठीक है, तो हमें इलेक्ट्रिक फील्ड चाहिए एट अ आर डिस्टेंस, लाइक दिस इज द लीनियर चार्ज having uniform linear charge density, and this lambda is the charge density per unit length, I mean q by l. Its SI unit is coulomb per meter. Okay, so let us say this is the line charge and at r distance from this line charge at here, what you find is that at this point you want to find the electric field. Okay, because of this line charge you want to find electric field at this point P, which is r distance from this line charge. Now this line charge extends up to infinity and this also extends up to infinity. So it's a long wire kind of stuff. So having uniform charge density, linear charge density. Okay. So let us try to understand the value at this point P. So what we will do is we will draw a Gaussian surface, something like this, and yeah, so here it is the Gaussian surface we have made. So the field lines will be something like this, the electric field lines will be something like this, and what you can see is the field lines will be parallel to the plane surface of this cylinder. So let us say this is surface A, this is surface B. So flux through the surface A is equal to flux through the surface B, and that is equal to 0. Okay, because these two surfaces have area vector perpendicular to the right. Now electric field is in this direction, so flux is 0. So now let's talk about flux through the surface C, which is the curved surface. So flux through the surface C will be electric field E and the curved surface area of the cylinder, that is 2 pi r and L. Let's say this is L, the length of the cylinder. Okay, so the total flux through the cylinder, that is very simple, it is E into 2 pi r into L, total flux, because you will add the flux through surface A, flux through surface B, flux through surface C, that will give you the sum total of flux through the cylinder. So that is going to be E into 2 pi r into L. Okay, now we can also write this total flux in terms of charge enclosed per upon epsilon naught. Okay, now this charge enclosed is the charge which is inside this Gaussian surface from here to here, that's having L length, and lambda is the linear charge density. So this upon epsilon naught, that will be the flux. So this one when equated with E into 2 pi r into L. Now it's very evident that L will be cancelled. So electric field will come to be lambda upon 2 pi epsilon naught r. Okay. So this can also be written as 2 multiplied to both sides. 2 and this is 2, so that becomes 4. So that can be written as 2 k lambda upon r, where k is equal to 1 upon 4 pi epsilon naught. Okay, so this was the final answer. You can remember this as well as this, and this k can be written as 9 into 10 raised to the power 9 in terms of SI units. And talking about the graph related to this question, so you will make a graph of electric field with distance. Electric field with distance from this line charge, that's r, so that will be inversely proportional to r. I mean, it will be something like this. E is inversely proportional to r. It's like this. Okay, so that's all about the first derivation. This was related to Gauss's law, and we'll talk about the next derivation.